Okay, circles means we already heard of these circles, remember? Simply we'll fix a point on a plane surface, we'll fix one point. From this point, one point will be, we are marking of one distance. Let us say the distance will be k distance. Okay, like that, in the same k distance, how many points will be there? There are infinitely many points in and around this fixed point, right? We mark this point as O. In and around this fixed point O, there will be infinitely many points which is in the same distance k. We connect all such points. See, here also one point will be there, is of the k distance itself. So the constant distance is there and we connect all such points, then the shape that we are having is called a circle. Okay, in this fixed point is called as center of the circle and this fixed distance is called as radius of the circle. Okay, that's all we know at this moment. And then there are three regions will be created. When we draw a circle in a plane surface, there will be three regions created. The regions are namely interior of the circle, and on the circle, the points on the circle, and outside, exterior of the circle. So the circle is splitting the plane surface into three regions. One is interior, the other is on the circle, the other is exterior. Suppose if I say a point A here and a point B here and a point C here, then this point A is called as interior point. Why an interior point? Because that lies in the interior. Okay, B is the point lies on the circle, like we say, and C is the point is the exterior point. Shall I say this interior point is center of the circle? Possible? No, it is not the center, somewhere else. Okay, is the center is the interior point or not? Center is the interior point, but not all the interior points are centers. Okay, now we understood this, a circle, what are their regions and all. Now we'll see the relationship between the circle and a straight line. Circle and straight line. So whenever we speak of this circle and straight line, three cases arise. Either that line will be a non-intersecting line, or it may be an intersecting line, the third scenario, this is not a circle, this may be a touching line. See, intersection is different, touching is different. Touching means at exactly one point. Okay, so here this is called non-intersecting line. Okay, obviously this intersecting line, no. If a line intersects at two different points, or else a line passing through 2 points on the circle, any 2 points on the circle, is called as secant of the circle. Okay, and then if a line touches the circle at exactly one point, then we call this line as tangent, and this point over there, this point is called as point of contact. Okay, point of contact. Alright, now we'll say how many lines are possible. This like secant, how many secants we can draw? How many secants you can draw, man? For a circle, to intersect in two different points, how many secants are possible? Infinitely many secants are possible. Likewise, for a circle, tangent, how many tangents will be possible? Infinitely many tangents are possible. A circle can have infinitely many tangents. See, this like one tangent we may have. Sorry, this like one tangent we may have. This like we may have one tangent, and then this like we may have one tangent. There is not tangent first of all. This is touches at exactly one point. So infinitely many tangents. But at one point, if we fixed it at one point, within this point of contact, how many tangents are possible? How many tangents are having this A as the tangent point of contact? The number of tangents possible on a point of a circle. The point on the circle. How many tangents possible, man? Exactly one and only one tangent possible. Okay. And this tangent is nothing but a special case of the secant. Is it? See, look at this point A and B. What happens? This points A and B is being coincident. Okay. So if the point A and B is coincide, then we will have that is a tangent. Okay. So tangent is a special case of the secant. That is it. And then the chord of a circle. Well, it is. You guys are noted down. Noted down or not, man? Say something. Shall I erase or not? Shall I erase? Okay. What about girls? Okay. Krish. Okay, good. Now, we have seen about secants, right? Secant is what? Secant is a line, straight line. What line? Straight line. It's not a straight line. It is a straight line. Okay, that is the reason why I am saying like this. See, Suppose if it is not a straight line, man, it's a line segment which touches the circle at exactly 2 points, intersecting the circle at 2 points, or else the line segment joining any 2 points on the circle is called as chord of a circle. Remember, how many chords are possible, man, for a circle? Infinitely many chords. Good. Among that, some chords may pass through the center. So the chord that passes through the center has a special name, man. Yes, diameter. How many diameters are possible? We have infinitely many diameters. Okay. Also, the line segment which connects the center with any other point on the circle is called as radius. How many radius is possible? Infinitely many radius is possible. Okay. So, the relationship between the circle and the line segment, everything we have seen, that line is non-intersecting line if it is not having any common point. It is called secant if the line and circle is having 2 common points. That means the line intersect the circles in 2 points. Okay. Or else in another way we phrase it like line passing through 2 points on the circle. Whatever it is, everything is there. Okay. It is called secant. Okay. If the line and the circle having the 1 common point, then we call it as tangent. And there are infinitely many tangents possible for a circle. At a given point, given 1 point, there is only 1 tangent possible. Okay. Clear? Also, tangent is a special case of the secant. So, with all these details, I forgot other one. The line segment that connects any 2 points on the circle is called chord. Suppose if it is a straight line, means what line? Straight line. Then this is called secant. Alright. And then with this, we'll start this theorem 10.1, which states that the radius of the circle is perpendicular to the tangent at the point of contact. Okay. The exact statement is the tangent at any point of a circle is perpendicular to the radius through the point of contact. So I wrote the opposite. The tangent of a circle is perpendicular to the radius at the point of contact. POC means point of contact. Okay. So to prove this, we need one circle. Okay. Let us consider a circle with center O and radius R. Okay. And let AB be the tangent at the point of contact let it be M. Okay. So here we'll draw this as a diagram. So this is a circle. The tangent AB we have, center O. Okay. The point of contact is M, like I taken. And then we need to prove that the radius is perpendicular to the tangent. No, the tangent is perpendicular to the radius. Okay. That means this OM is perpendicular to AB, like we have to prove it. We are going to use that one method. The shortest distance between the point and line, you know what? the shortest distance between the point and line. The perpendicular distance. The perpendicular distance is the shortest distance, So we are going to prove this is the shortest distance. To make it this the shortest distance, you should be taking longer than this. Okay. Let us consider a point. Let P be another point on AB such that P is not equal to M. No, this like you should not write. Another point on AB P be another point on AB other than M, like you can write. So we'll take either way. Here I am taking the point P. Now we just connect or join OP which intersect the circle at R, let us say. So we are connecting this point OP which is intersecting at R. Okay. So clearly we have OM is equals to OR, man. Why? Because that is radius. Also, what about this OP? This OM and OP we can compare. Whether this OM is less than OP or greater than OP. It is less than OP. Okay. That means what? This OM is less than OR plus RP, man. Okay. This and all not needed. Simply this is the OM is less than OP. So, for any point on AB other than P, so not other than P, other than M, if we take means we have OM will be less than that. Why it is less than? Because this is OR plus RP. It's more than the radius. That is why this step is important. Here we should write this step. So it's more than the radius. OM is just radius. When we add something to radius, it must be greater. Okay. Then here, for all the points, like we said, then what about OM, man? OM is the shortest distance between O and AB, and we know that, so I erase this one. We know that the shortest distance between the point and line is the perpendicular distance. Is it or not, man? You take a point and a line. Which distance will be shorter? This is shorter or this is shorter? You take at any point near to this also. This one is the shortest distance. We studied in 9th class, remember? We proved this as well. Okay. So therefore, the tangent, no, it's in place. We have AB is perpendicular to OM, which is the radius. So we get the result that tangent is perpendicular to radius. This is very important results that we are using this throughout this chapter. Alright. Have you written all this? Shall I erase? Okay. Now look at the exercise 10.1. The exercise 10.1 which states that how many tangents can a circle have? It's the first question. How many tangents possible? Infinitely many tangents it may have. And then a tangent to a circle intersect that in how many points? Dash points, like they gave. 1 point. Cleverly they gave bracket in bracket S. Point or points. Okay. So 1 point is the answer. A line intersecting a circle in 2 points is called, read it carefully, a line, it's not a line segment, line intersecting the circle in 2 points is called as secant. Okay. A circle can have dash parallel tangents at the most 2. Why it is 2, you know? Shall I erase this? See, a circle can have 2 parallel tangents at the most. Why don't it have dislike and all? Dislike also possible, right? So they are asking about parallel tangents, not about pair of tangents. Pair of parallel tangents means we may say infinitely many tangents, because dislike many such pairs are there, pair of parallel tangents. But as a parallel line, this is 1 line, 2 line, 3 line, that like you say, right? So if this acts like a tangent means only 2 lines we can write. Third line if you want to draw also, it will be parallel, but it is not a tangent. That is why it is having at most 2 parallel tangents. So read it carefully. If it is pair of parallel tangents, now you may say infinitely many, because that many infinite many pairs are there. But when it is simply parallel tangent, now how many lines can be drawn parallel such that they are the tangents? Only 2 lines you can draw like that. So it is 2. Got it? And then a common point of a tangent to a circle and the circle is called common point for the tangent and the circle. Point of contact, POC, like I wrote this somewhere. Okay. And then the third question, it is about says that a tangent PQ at a point P of a circle of radius 5 cm meets a line through O at the center at the point Q. Confusing, is it? They say tangent PQ a tangent PQ at a point P of a circle. That means P is at the point, P is at the circle, point P on the circle, and then 5 cm, radius is 5 cm. So we have radius is 5 cm, meets a line through the center at the point center O at a point Q. So that OQ 12 cm. That is, then the length of PQ like this distance. Okay, we can't do this directly, but with the help of this theorem that we studied right now, the radius is perpendicular to the tangent, right? As this is a MCQ or 1 mark question, we are not writing descriptive answer. But when it comes to the descriptive answer, suppose they ask the same question in the 2 mark, we are supposed to write why it is a right angle triangle also. So the triangle POQ is the right angle triangle. Why? Because radius is perpendicular to the tangents by theorem. That statement should be mentioned. Okay, if MCQ, no need. But in case descriptive, I am saying. Okay. So right angle triangle. By what theorem, man? You speak of right angle triangle, immediately you speak of Pythagoras, our guy. What he said? The hypotenuse square, 12 square is equal to sum of squares of other 2 sides. So it is 144 minus 25 is equals PQ square, and PQ is equals to square root of 119 centimeter. Says option D. And then The question number 4 that states that draw a circle and two lines parallel to the given line such that one is a tangent and the other is a secant to a circle. Easy. You have to draw, man. This is question number 3. We can draw a circle. Like that, two lines should be parallel. One should be the secant and one should be the tangent. You name the line L and M. L is a secant, M is a tangent at the point of contact P. Okay, that is all. We finished the exercise 1. Shall we start exercise 2? Shall we? Shall I erase everything? You guys have any doubts in this exercise 1? Any confusions? Good.